Welcome. Now we are trying to describe you the geometry description language for pre-engineered buildings. The polygon nomenclature system is very important for describing the geometry of plates which we cut in fabrication systems. First of all, we will explain here the standard and specification for the peoples who work with AutoCAD LT and try to get the nesting data automatically generated in SAP or for ERP systems, and many people who wants to type data in a table and they want to get the fabrication drawings in scale in the DXF format such that they can import that in plasma cutting systems or in the nesting systems such that they can get the plate nesting properly. To do all these things, people need to understand the geometry description language, that is the polygon description language, with which they can explain the nature of cuts and the thickness wise web shapes or thickness wise stiffener shapes, or for different kind of clips people need to enter the geometry data into the tables so that we can get the geometry files generated automatically for multiple purpose. Some are for entering the data for material masters. Sometimes the data is necessary for bill of materials, for purchase planning, and sometimes the data is necessary for material handling in plant or in store. Sometimes these data are very much important to do plate nesting on the nesting softwares or for plasma cutting systems. In pre-engineered building fabrication systems or for any such kind of fabrication systems where multiple shapes of polygons are involved, in those cases one fabrication drawing automatically have multiple number of polygon objects to interact with each other. But some conventions are very common in pre-engineered structures, like the flanges are normally rectangular, sometimes they have some back cut. Waves are the most critical thing in pre-engineered structures because waves have multiple kind of trapeziums, sometimes triangles, and sometimes pentagons, sometimes there are hexagons present in the wave. But in common practice we have seen when we draw the fabrication drawings, then flanges are rectangular or sometimes having the back cuts and sometimes having some notches at left top or on the left bottom or on the right top or on the right bottom. As per the fabrication drawing convention, the one side of the wave is straight and it is kept straight at the top, and the other side has a zigzag conditions which are taken as the multiple shapes which are necessary to do merging at the software level. Suppose the draftsperson or the detailer is drawing the whole wave as a single piece, but when the thickness is changing they draw it in multiple pieces. Sometimes even when the thickness are not changed, still they want to describe the geometry piecewise, and whenever they will try to type it as a WB1A, WB1B, WB1C in this way up to 6 values, then it is considered that this 1A is on the leftmost side, 1B is coming next, 1C is coming next. In this way 6 different kinds of wave shapes are included there. Suppose we want to describe it in this way. Suppose one wave is small, another wave is longer, and if we merge these two waves, suppose we are merging these two waves here, and then we are taking the waves like this, then we can see that WB1A is placed on the left side, WB1B is taken on the next object, WB1C comes next, and in this way we construct the webs suppose we are drawing it in this way, WB1A, then WB1B. We can think it as if the WB1A is kept on the left side and WB1B is kept in this way, and if we draw it splitted, then it looks like this. If we don't draw it splitted, then it is drawn like this. This is the left web's left width, this is the right width, and for the WB1B cases, this left width of the WB1B becomes same as the right width of WB1A, but the length is added. The length of WB1A is added to the WB1B. In the same way, if we take WB1C merged at this point, and if we consider the stretching of this is taken as this, then we have to redefine the meaning of this left width and right width, and we can think it as the object is splitted and there is a top back cut, and it is not back cut, the negative back cut is considered here. Here the back cut means something interesting. The back cut is described here such that the back cut means the cut towards the material, and when it is a positive back cut, then it is like this. For example, if there is a left back cut, then we describe it like this, as if this kind of ortho movement is done. This one is a positive back cut, and if we take it like this, stretch along this outside, then it is the negative back cut. So with the back cut, we can define the nature of the webs, and the shapes of the web start with the crude rectangle first, and then left width and right width describe its nature of the polygon, and with the back cut we can describe this kind of web cuts. And whenever the multiple thickness objects are aligned in this way, then we can take it as the multiple webs are attached, and so forming a single web object, and whose length is the total length. And our software can automatically see whenever WB1 series is there. When WB1 series is present, then it will add all the webs as the main web, and total length from AABB, that is axially aligned bounding box, it will take the total length of the web as the length of the object. So we have to fill the data like WB1A, WB1B, WB1C in this way, row wise. We will describe the web data, then it can describe any kind of webs like this. And if we fill the data for different conditions of the webs of different shapes, then we can describe these shapes easily, and we can describe any such shapes easily with any kind of web depths, and then it becomes easy for anyone to describe the PEB shapes for any kind of webs. We know due to the arrangement of fabrication is done such that one side of the flange is always kept straight and other side of web is zigzag. So it is the best way to describe the webs in the table in such a way. And if there is a left top notch or at the bottom right notch or left bottom notch, then notch has a width and notch has a depth. And in the geometry description languages, there is the option for the left width, right width, left back cut, right back cut, left top notch, right top notch, left bottom notch, right bottom notch. And we put the comma separated values for the notches, that is width comma height. The width is in millimeter and height is also in millimeter. If we put the comma separated values in these notch values in the table, then it will automatically understand how to draw the fabrication drawings for every piece, or such that in the DXF files we draw the pieces of the constructions, because when our system runs, suppose in this drawing, when our system see there is a rectangle with title layer, in red color title layer, then it understands that it is a fabrication drawing. Normally in Indian environment, our detailers draw the images in single file, draw the CAD drawings for fabrication drawing in a single file, and when our system runs, then it automatically reads this data, and from the table it automatically understands the shape of the main wave, WB1A, WB1B, WB1C, in this way up to WB1F. It can consider any waves of multiple thicknesses or of the same thicknesses, but geometry are changing. In this way, it can automatically understand the nature of the wave, and it draws the combined wave also. And also there is a condition that in Indian PAB 6 meter maximum length is used for the stock management systems. So 6 meter breakup is also done in fabrication systems. So anyone want to manage these whole things like this, and sometimes the crane brackets are also there, that is done with the splitted wave, that is the WB2. And in that cases, if we take it as a WB2, then it will consider it as the non-main wave, and it will consider it as the second wave which is attached to the end of the first wave, like laterally. It will not take it as longitudinal case as in the previous cases where it is taken like this. And so WB2 cases are special cases, because WB2 cases are taken as a different series of waves which are not the main wave, because main wave are all in the WB1 series. WB1 series means they are longitudinally placed. WB2 series means these are like crane brackets which are taken separately. And for the WB2 cases, we can have the back cuts, and it can have the different geometry conditions. And suppose in the WB2 cases, we can draw it in this way, and here we will do the stretching. Here we will do stretching, and stretching is necessary to get the different back cuts and different waves which we do when we prepare the fabrication drawings for crane brackets or like that, where this side is kept straight and one side is slant as per the optimization rules used for structural designing. And for different kind of geometry, we can think it as the separate wave entities. The WB2 series means it is the lateral wave object, it is not the longitudinal wave object. The longitudinal wave objects are kept like this, and the lateral wave objects are separately placed. Sometimes the lateral wave object and the longitudinal wave objects are merged with the same thickness. Then also we can have the instruction in the table. We will write in the bracket that WB1C equal to WB2C or slash WB2B. In that way we can instruct the software that there is a merged line between these. And this is also covered in the geometrifying trigonometry, that when several line segments are merged, and these are very applicable geometry description languages in construction industry. In this way we can think of the geometry are described properly in the table. Software can automatically read the data and prepare the lengths of this. And in the previous video we have shown that length calculation and weight calculations are already done automatically from the tables, from the table data. And there are the facilities to read the polygons. If you construct the stiffener items or clip items or web items as proper polygons, normally our modelers don't do everything with proper conventions. If they prepare the data with proper layer, like web 1 layer, web 2 layer, and the polygons are made with the proper geometry to the scale, then software can read that geometry from the polygon and cross verify the dimensions are filled in this table properly or not. And there is a separate software which reads the polygon data from the drawings and can automatically generate these tables as per the necessary conditions of our fabrication drawings in PEB. There is a geometry description languages, the polygon description language, and unique polygon nomenclature system also help us to search the right objects from the SAP database or from ERP database to help everyone to do the material management, to do the stock management, and also for the fabrication management systems where there is a life cycle in the fabrication. There are several stages of the fabrication, and we can manage all these systems in a sequential way or in the parallel way if the data are completely filled properly. Even in fabrication drawing, we can instruct with the other columns to maintain the fabricability conditions. Suppose if we want to do it in the phase 1 or in the phase 2, there are the options here. If we fill the data properly, like in the building number, phase number, and the finish color code or the finish instructions, and if we put the instruction here in the fabrication drawing or in the columns properly with the fabrication instruction system, or if the special case is to take care, we can handle it in the columns. Then our software can write the necessary remarks for the ERP or SAP systems, and that helps the whole process of ERP or the whole process of fabrication management systems, and also post-sales support systems also, such that if someday we need to revise any part of the building, that is also trackable very easily, because from this table data or from the proper geometry data we can generate QR codes or the barcodes for the objects. And in the transport management systems also, that helps to track the objects at the real time from any situation, from any location of the world. And these are the parts of the pre-engineered building systems: automated data scanning from CAD drawings and to handling the data with the ERP or SAP systems. It helps the prefabrication systems very easily and in a standardized way. Thank you.